Yes, in this video we will discuss the Coulombs law. Last time we discussed the methods of charging and the basics of electric charge. Today we will discuss this Coulombs law. And see, Coulombs law is actually uh, given by obviously scientist Coulomb, and actually he performed the experiment of torsion balance. So by the experiment of torsion balance, he gave this Coulomb's law, or this law, and this is about the electrical force. This law is about the electrical force. Sometimes it is called electrostatic force. See, electrical force or electrostatic force. Actually, these two are same. Electrical force, it is between the two charges or 2 point charges, and उसमें भी थोड़ा अगर हम एडिशन करें तो 2 point स्टेशनरी चार्जेस, बिकॉज इसीलिए हमने इसको क्या बोला है, इलेक्ट्रोस्टैटिक. स्टैटिक मीन्स स्टेडी, here steady means electric charges are steady, and this force is between the 2 point charges or 2 point stationary charges. So this force is directly proportional to the product of the magnitude of these 2 point charges and inversely proportional to the square of the distance between or separation between them. So this is the equation of Coulomb's law or Coulomb's force. It is also known as Coulomb's force, and obviously here charges are of two types, positive and negative, and that's why this force are of two types. This force is of two types because like charges repel each other and unlike charges attract each other. So this force is attractive as well as repulsive in nature. So this force is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between the two charges or separation between the two charges, and it is directed along the line joining the two charges, something like this, q1 q2. ऑब्वियसली उसका डायरेक्शन हम लोग जब वेक्टर फॉर्म इसका डिस्कस करेंगे तब देखेंगे. हियर सेपरेशन आर इज along the line joining the two charges q1 to q2. Medium, initially we are taking free space, or also we can say that vacuum, this, and here proportionality constant is F is equal to K q1 q2 upon r square. Here K is the proportionality constant and K is known as Coulomb constant. K is called Coulomb constant. Its value is 9 into 10 raised to 9. This is in SI unit system, and its unit will be like this: Newton into meter square per Coulomb square. See, unit of force is Newton, r square means meter square, and q1 q2 means Coulomb into Coulomb. वो डिवाइड में आ जाएगा यहाँ पे, so it is Coulomb square. In CGS its value is 1, because वो सिंपल सा है कि CGS unit of charge is state coulomb or electrostatic unit ESU. ये जनरली हम ये यूनिट यूज करते हैं. And if we take the relation of Newton, it is in SI unit of force. Newton is the SI unit of force, meter is the SI unit of length, and Coulomb is the SI unit of charge. Now if we convert this into the CGS unit. By the calculation we will get this. Very simple. It is 1 coulomb is equal to 3 into 10 raised to 9 state coulomb. So by using that conversion we can derive this k equal to 1. So this k equal to 9 into 10 raised to 9 in SI, and CGS it is this k equal to 1 CGS. Okay, then also we can say that here k is equal to 1 upon 4 pi epsilon naught. See here 4 pi is constant, but epsilon naught, actually epsilon naught is the permittivity of the intervening medium between the two charges. So here epsilon naught is the permittivity of free space. So epsilon naught is the permittivity of free space, and its value is 8.85 into 10 raised to minus 12, or obviously this is the k is equal to 1 upon 4 pi epsilon naught is in divide here, so unit will be something like this, coulomb square पर न्यूटन इंटू मीटर स्क्वायर, इसका रेसिप्रोकल हो जाएगा. सो एप्सिलॉन नॉट इज 8.85 इंटू 10 रेज टू माइनस 12 कूलम स्क्वायर पर न्यूटन इंटू मीटर स्क्वायर. So see, this force is when the medium is this free space or vacuum. It means there is an important role of medium. So here it is very simple. Okay, when there is a free space, the force is given by this equation, F is equal to k q1 q2 by r square. Also we can write something like this, 1 upon 4 pi epsilon naught q1 q2 by r square. So इस तरह से भी हम लिख सकते हैं इसको, because k is 1 upon 4 pi epsilon naught q1 q2 by r square. तो दोनों सेम ही है, यहाँ पे हमने k का वैल्यू वहाँ पे सब्स्टिट्यूट किया है. सो इट इज़ वेरी सिंपल. नाउ सी दिस फोर्स इज फॉर दिस मीडियम, फ्री स्पेस और वैक्यूम. It means if we change the medium, so obviously the change in the magnitude of the force or electrical force or electrostatic force. So why there is a change in the magnitude of the force? Because actually permittivity shows that how strongly the electric force or the electric field, actually charges or stationary charges produces the electric field. So this how strongly this electric field or electric force affect the medium, that is about the permittivity of free space. ऐसा भी बोल सकते हैं कि how it affect the magnitude of the force, medium affect the magnitude of the force. तो ऐसी बात भी है. Actually it is about the polarization. So this is when we put the two charges in the given medium, so there is a polarization in the medium. Generally we are using dielectric medium. Dielectric medium, it means non-conducting materials. It is made up of non-conducting materials. So in this type of medium, when we fill or when we insert the medium between the two charges, or the surrounding is of suppose dielectric or of insulator, so there is a polarization due to the effect of these two charges. There is a polarization inside the medium, and this polarization actually here it is given by the permittivity. This is the permittivity of free space for any medium. It is given by something like this. For any medium it is epsilon. When we divide it by epsilon naught, it is the permittivity of free space. So this is the permittivity of any medium with respect to free space is called relative permittivity. So this is called relative permittivity. its another symbol is capital K. This is small k. This is capital K. Small k is Coulomb's constant, while capital K is dielectric constant. This is dielectric constant. Ready? Or this is relative permittivity. So this is relative permittivity and this is dielectric constant. Both are same. And obviously here epsilon is given by this K epsilon naught. So when we use this formula for any medium, ready? So for the given medium, force is given by this equation 1 upon 4 pi K epsilon naught Q1 Q2 by R square. इसको हम बोल देते हैं फोर्स इन द गिवन मीडियम, ऐसा बोल देते हैं FM. And this is F in the free space and this is FM in the given medium. So obviously when we divide this two equation, when we take the ratio of these two equation, so we will get the relation something like this, because ये भी हम ये डिवाइड कर रहे हैं हम 1 upon 4 pi epsilon naught Q1 Q2 by R square. Here 1 upon 4 pi K epsilon naught Q1 Q2 by R square. So it is something like this. Fm is equal to F by K. So in the given medium, force will be 1 upon K times. Ready? So force in the given medium between the two stationary charges is 1 upon K times the force in the free space between the two stationary charges. So this is the basic information about the Coulombs law. Thank you.